Hi students, what we're going to do right now is go through a PowerPoint together, and I refer to this PowerPoint as a mindset PowerPoint. And the purpose of this is to kind of get you in a position or a frame of mind where you're able to get as much out of this course as you possibly can. I realize that a lot of students have had bad experiences with mathematics in their previous life as a student. Maybe some of you haven't, and if that's the case, that's great. But if you have had a bad experience in mathematics, I want you to look at it from the perspective of, hey, it wasn't me. It was probably the way the math was taught to me, and use that as motivation for wanting to be the best math teacher that you can be once you're in the classroom. So the first thing we'll talk about is the course objectives, and this is kind of just a big picture. You can find more specific objectives on the course syllabi, but obviously we want to expand your knowledge of elementary school mathematics, and that's going to mean a lot more than just going through, practicing the algorithms to do long division and that kind of thing. We're going to go into a lot more depth than that. So here's the list of topics. So the first unit that we'll do, and it's chapter 1 in the book, is problem solving. So we are going to look at what does problem solving actually mean in an elementary classroom and do some work with that. Chapter 2 is numeration systems. This is one of my favorites because this is really getting to the root of when children first learn mathematics. And what does it mean to learn how to count, and what does it mean to be able to record those numbers symbolically? Chapter 3 is whole numbers and operations. So it's probably hard for you to remember what it was like before you knew what it meant to add or subtract or multiply or divide, before your brain was conditioned to see that plus sign and know exactly what to do with two numbers. Chapter 4 is whole numbers and operations, and these are things like the long division algorithms. Why do we carry? Why do we borrow? Why do you bring down when you're doing long division? Students have a lot of aha moments during this chapter. We work on something called number theory. Chapter 6 is a big one. It is rational numbers as fractions. And a lot of people really struggled with fractions, and I believe that that's because fractions really are taught in a crazy way. So we're going to look at a brand new way of teaching fractions and hope that we can kind of rebuild from the ground up if fractions are not your friends. We also look at rational numbers expressed as decimals and percents, and we also work with the real number system and a little bit of algebra. So another course objective is for you to become an accomplished learner of mathematics. So in this short period of time, there's no way that I can teach you everything that you need to know or that you might be teaching your students. We just don't have enough time to go totally into depth. But what I want you to experience is learning several mathematics topics in a lot of depth, and coming to a realization of what it means to really know mathematics, what it means to have it actually make sense. So that later on, if you're teaching a topic that we haven't covered in this class, that you are able to do that learning on your own, and that you're able to recognize, hey, I've really got it, and I'll be able to convey this to my students. So I also expect that this course will kind of shake up your beliefs about what it means to know and learn and teach mathematics. You've been conditioned, most of you, to look at mathematics from what I call a procedural approach, which essentially means the teacher shows you the steps to follow, you learn those steps, you practice those steps, and then you take a test on those steps. And I kind of have to shake that belief out of you, because that really is not what mathematics learning should be all about. So this course is not what's called a methods course. So a methods course would be one that would actually teach you how to teach math in the classroom. So, classroom management type things. So this is not a methods course. We're working more on the mathematics that you need to know so that later you will be able to focus on how do you convey that information to your students. So what does it mean to know mathematics? I'm a big analogy person, and there's several different analogies that I've got that I'm going to show you on these screens. Not all of them may mean a lot to you, but hopefully at least one of them gives you an aha. So here's my first analogy. We see this structure here, and the thing I like about this structure is that it's totally transparent, and essentially every little ball is attached to another little ball as long as I follow, the path from one to the other. And that's really how I want you to come to view mathematics. I want you to see it transparently. I don't want it to seem mysterious to you at all. Like, hey, I don't understand why you do this. I just know you're supposed to do this. I want you to understand all of it. I want you to see how everything is connected and how things begin to make sense as you are learning mathematics in the correct way. So one of my favorite movies, The Wizard of Oz, I think of sometimes people learning mathematics in that same way as, meeting the Wizard of Oz for the first time. It's a great and powerful Oz, intimidating, scary. You don't have any idea what's really going on. But I really believe math shouldn't be like that, in that mathematics is really all about what's going on behind the curtain. And that's what we want to be able to share with students. So here's another analogy. Like I said, several of them, hopefully one of them at least will speak to you. So here's my analogy to learning to bake. And I happen to love to bake, but there was a time in my life where I was terrible at it. But then I got pretty good. So step one of learning to bake is, you can't bake anything to save your life. And there are people who are like that. I was one of them. And then, you can use a box mix and make something. And I don't know if that really counts as being able to bake or not. That's a good question. Being able to follow a recipe and make like a cake from scratch. To me, that's getting there. People who are good bakers, to me, know the tricks of the trade. So you can follow a recipe and make it taste better than anyone else does. So I know, there are tricks of how to measure flour, making sure the butter is soft enough, all that kind of thing. In this internet age, a lot of times I get recipes off the internet, and every once in a while one will flop, and I'll look at it and I'll say, oh, I should have realized, based on the ratio of leavening ingredients or something, I should have realized this wasn't going to work. You just kind of get to know it well enough. And then, recipes, somebody has to make them up in the first place. So, to me, the master bakers are the ones who can make their own recipes. So let's relate that to learning how to add fractions. So, analogous to not being able to bake anything to save your life would be, I have no idea how to add fractions. And then, to me, the same thing as being able to follow a box mix or use a box mix to make a cake is adding fractions following the steps that the teacher gave you. Do you really know how to add fractions if all you're doing is repeating exactly what they did? I think once students understand that when you add fractions that you do have to have common denominators, but they don't have to be what we call the least common denominator. If I have a student who can explain that to me, I feel pretty good about their understanding. But the best thing is when a student can explain why you add fractions the way you do. Why do you have to have common denominators? Why do you only add the numerators? When they can really explain the why rather than just the how, that's when they really understand the mathematics. All right, so this comes from a board game that my girls had years ago. So just pause. I'm going to pause for like 15 seconds or so. Look at this picture, trying to memorize as many details as possible. All right, so time is up. How many pieces of paper are on the floor? Okay, so the answer clearly is that there are 3 pieces of paper. All right, what's the point of this? I don't want you, if you felt that moment of seeing that question and having no idea what the answer was, that's supposed to make you think of that moment when you would be standing up in front of your classroom and a student asks you a question and you have no idea what the answer is. So they say, why do you have to do that? Or can't I do it that way? And you don't have an answer. And we don't want you to have that feeling. Most students have had at least one experience with teachers who refused to answer student questions. And they would kind of have their ways of avoiding questions like, you know, you'd really learn that better if you were to read it in the book by yourself rather than me tell you. Or, we already covered that. You need to go back and look at your notes. Or, you know, just being mean and intimidating and making people not ask them in the first place. And I think, unfortunately, most teachers who do that, the reason they put off those questions is because they don't know the answer to the questions. And we don't want you to be that teacher, obviously. So here's a little diagram that my daughter drew for me years ago based on kind of a picture I had in my head. And so I think a lot of people experience mathematics in this mode, where the teacher is ripping pages out of the math book and basically saying, here, learn this. And you know, swallow, quick, we got to move on to the next page. And so they experience mathematics with just the teacher force feeding them what they're supposed to be doing and doing it at a pretty quick pace. So we hope that's not the way that mathematics is going to be taught by you. So here's another option. Another option is, you know, think about what it means to really learn how to do something, such as rollerblading or riding a bike. That's something you have to figure out on your own. And once you figure it out on your own, it becomes your own personalized knowledge. And then that personalized knowledge gets filed away in your brain. And, you know, there's a reason for that saying, you never forget how to ride a bike. It's because you figured it out on your own. Nobody else told you how to do that. So here's my goal for you. So there are some stages when you're learning something. So the first thing is unconscious incompetence. Have you ever had the feeling where you don't even know what you don't know? When I began being an academic advisor, I definitely was in this situation. I had no idea everything I would need to learn to be good at my job. The next step when you're learning something is what we call conscious incompetence. So I went from unconscious incompetence. So day one of my job, I didn't even know what I didn't need to know. I was like, this can't be too hard. Very quickly into my first day as an advisor, I got to conscious incompetence. I realized how much I didn't know and how much I was going to need to learn. I think after 2.5 years or so of being an academic advisor, I'm finally to the conscious competence stage most days. So I still have to think about it. It doesn't come naturally to me. I have to work at it, but I've got it. And on my best days, I am at the point of unconscious competence, meaning it's second nature to me. I've done it so much now that I've really got it and I don't have to think about it. So in terms of elementary mathematics, I hope to get you to the point of conscious competence in this course, and I hope that you will find in your mathematics teaching career that you get to unconscious competence. So I challenge you to think about something in your life that you've gone through these stages with, because I think that's instrumental. And I'm